In this video, I'll teach something called the induction. Now, when you use proof by mathematical induction, you're basically proving this whole sequence is equal to this number pattern. So basically, this is the equation of the number pattern and you need to prove it. Always you follow these steps. The first thing, you want to prove something called a base case. Now, what does a base case mean? Base case means if you let's say this equals to 1, all the n equals to 1. That means 1 is the first position. So you know this is the first position. So you should get this as an answer. So if I let n equal to 1, I should get what's the first position, which is this term over here. So this implies 1 over 1 plus 1. And what is that equals to? That is equals to 1 over 2. And 1 over 2 is technically this, right? So you can rewrite 2 as 1 times 2. Same thing. So this is true. So the base case over here is true. Now the second thing what is called the induction process. And I want you to think of this like this. You see this number pattern over here? You copy it down. But wherever you see n, I want you to put k. So copy this whole thing down, but wherever you see n, put k. So that will be 1 over 1 times 2 plus 1 over 2 times 3. I'm just copying it down. Nothing wrong. Dot 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 plus 1 over, now wherever I see n I put k, so k plus 1, which is equals to k over k plus 1. Perfect. Now wherever I see n I put k, but now wherever I see n, now this is the second step of the induction, I want to put k plus 1. So I'll just do that, right? So let me copy the pattern down just as I did above. Now when we come to this stage over here, plus I'll copy this down too, right? Because I'm copying what I did before also, but I added to the number pattern. But what I'm going to say here now, it's going to be plus, and what's the next term after this? It'll be plus 1 of this term, right? So I'll say 1 over k plus 1, so wherever I see k I put plus 1, times k plus 1 plus 1, that's k plus 2. So you see, so I'm just adding 1, and this whole thing over here is equal to, when I put k plus 1 in this, so k plus 1 over k plus 1 plus 1, so k plus 1 over k plus 2, k plus 1 over k plus 2. Now here's the thing, this whole thing over here is equal to k plus 1, and this whole thing over here, you can see it, it's the exact same. So I can make that k plus 1, right? Because the whole thing is equal to k over k plus 1. So k over k plus 1, so I'm just simplifying it, plus, now obviously this is, I got it, but now I have to do this one. So it's 1 over k plus 1 times k plus 2. And obviously this is going to be equals to k plus 1 over k plus 2. Now somehow this should be equal to the left. I mean the left hand side should be equal to the right hand side. So what I'm going to try to do is make this left hand side equal to this. So I'm going to join this addition. So obviously I'm going to make this into a 1 fraction. So the common factors are k plus 1 and k plus 2. How many times k plus 1 goes there? K plus 2 times. So k times k plus 2. So you can do it like now. So k squared plus 2k. And then over here, k plus 1 goes into that 1 time, k plus 2 goes 1 time, perfect. So 1 times 1 is plus 1. And you can basically further simplify this, right? So let's just carry down this equal to sign. Now what I'm saying in further simplify, you see this k squared plus 2k plus 1. Can't I write it as this? As k plus 1 all squared? Can't, because k squared plus 2k plus 1, the binomial, and k plus 1 over k plus 2. Now what's happening over here? This 2 will turn into 1 and it'll cancel this out, right? So you'll have to k plus 1 over k plus 2, which is equals to k plus 1 over k plus 2. This and this is same, this and this is same. So you prove that this is equal to this. That is how you prove mathematical induction. Therefore, you do a conclusion. Therefore, this is equal to this. So you just rewrite that and done.